next speaker is Lak. He's going to talk about the Vertex AI, which is newly released in the, I think a few months back in the Google I/O events. It's a great platform to unify many of the resources for machine learning and AI tasks. Lak, he is the director of data analytics and AI solutions on Google Cloud. And his team builds software solutions for business problems using Google Cloud's data analytics and machine learning products. He founded Google's Advanced Solution Lab, machine learning immersive program, and is author of several oral books and career courses. Without further ado, let's welcome Lak.
Thank you, Bill. Hello, everyone. Today I'm going to be talking about machine learning pipelines, specifically prefabricated machine learning pipelines in Vertex AI. So what is Vertex AI? It's essentially a set of tools for predictions, for training, for evaluation, for monitoring. So essentially a set of tools that supports your entire workflow across different model types: AutoML, TensorFlow, PyTorch, scikit-learn, right? Whatever framework you're using, and different levels of ML expertise, whether you want to use low code, whether you want to use no code with AutoML, or you want to basically use low code with BigQuery ML, or you want to basically do sophisticated programming with TensorFlow or PyTorch. It supports all of the different types of ML expertise. So what's in Vertex AI? If you think about the machine learning workflow on the top, data readiness, getting your data ready, labeling it, for example, feature engineering, right? Creating a data set, training or hyperparameter tuning, then serving the model, understanding it, tuning it, deploying it to the edge, monitoring the model, managing the model. There's different tools that support that full end-to-end workflow. And again, as I said, you could do it with no code with AutoML for things like vision, video, language, translation. So when we talk about AutoML, what we're basically saying is using the state-of-the-art models with a point-and-click interface. But at the same time, you can also build things yourself. So you can you can build things that can be trained, hyperparameter tune, run experiments, use GPUs, do predictions, explainability, all of these things. And as you build an ML pipeline, right, you will want to orchestrate it. You don't want to basically do them one at a time. You want to connect them together, and that connection is what a pipeline is. And all of these are a unified workflow. So once you create a data set, you can use that same data set to train both an AutoML model and a custom model. So you're not doing completely separate workflows just because you're changing the way you're doing. Like, for example, if you have things in a feature store, you can use it to support both PyTorch and TensorFlow models. That's the basic idea, is that all of these things are loosely connected, and that you can combine them in the way that you want to solve your problem. So the tools that you're using can be, like, as I said, user interface based, low code, or it can be programmatic. So everything that you can do on the UI, you can also do with a nice software development kit, an SDK. And of course, today I'm going to be focusing primarily on the right-hand side, using the SDK to develop models. So, but once you develop a model, that's not it, right? So you develop the model, you deploy it, but then you want to basically monitor it, retrain it, update it. And once you have these kinds of complex different steps that you want to do, automation becomes extremely important, and that's where pipelines come in. So when you think about a very simple view of a pipeline, it lets you do experimentation, try out different hyperparameters, try out different types of models, etc. It allows you to do training and later on to retrain the model. It allows you to deploy the model and then monitor it. And you want to basically do a variety of things during that entire process. And that's what pipelines help you do. Okay. Now, How does Vertex AI help there? Well, with all of the automation, it helps you do things like experiments, try out different things. It helps you reuse features. It helps you do continuous monitoring, helps you manage metadata throughout the entire process. But most of all, it allows you to orchestrate all of these things automatically with caching, with dependency tracking in an ML pipeline. However, pipelines can be hard. And one of the things that we firmly believe in is that simple things should be simple and hard things should be possible. So pipelines make hard things possible, right? So when you talk about a pipeline, you're talking about hard things like A/B testing, performance monitoring, comparing different experiments, etc. So that's great. It's great that it lets you do these hard things. It lets you do feature stores, experiments, continuous monitoring, edge deployment, metadata tracking. But what if you want to do something simple? All I want to do is to develop a model. And in order to do that, I want to basically create a data set that I can version, that I know what data I'm using to train my model. I want to train my model and not just train one model. I want to tune the hyperparameters. I want to also try out AutoML. So a little bit of experimentation, deploy that model and get predictions. Well, this is the simple workflow. And I think this workflow is like 90% of what you will do day to day, right? So how do you do this simple workflow? Let's forget all the complexities. Let's forget all the sophisticated stuff. How do you do this simple workflow, developing a model, training it, tuning it, AutoML, deploy to an endpoint, get predictions? How do we do that in a simple way, right? So let's start. First step is that you want to develop a model. This is the thing that every data scientist, like, every tutorial, that's what it talks about, right? So you go to a notebook, you write some code. And in that code, you can basically have direct connections to things like BigQuery, Dataproc, Spark, other things. You want to be able to maybe even schedule the notebook. You want to write the code in PyTorch, or you want to write the code in TensorFlow, etc. So you do that in a notebook. In Vertex AI, that's a Vertex AI workbench. Okay? So inside the notebook, then, you basically will write Keras code. That's going to be my example. So you will read a data set, create a training data set, you will create an evaluation data set, you will create a Keras model, you will basically train the model, and you will save the model. This is your normal Keras workflow. And let's just assume that that's basically what we're going to do. So what I'm doing here is that I'm just opening up Jupyter Lab, right from my Vertex AI. And at this point, I'm basically in the Jupyter UI. I can git clone the repo here, right? But let me just go ahead and do it from the command line. And let me do git clone github.com. And I'll do the data science on GCP. Okay. And move into that. Let me move to the branch edition 2, right? So there we are. And in here is my notebook, right? So I can basically go ahead and say that I want to basically use Python 3, right? Now I'm in my notebook, and this should be pretty familiar to anybody, right? So if I want, right, I basically out here, I'm basically saying that I want to train my notebook on US Central 1, right? This is my bucket. This is my project. And here I'm running a BigQuery query to basically go pull some data, do some data preparation, and create a brand new table called training data, and another new table called evaluation data, right? And then having done that, I'm basically going ahead and extracting it out into cloud storage. I can read the data directly from BigQuery. There's a BigQuery reader in TensorFlow, but it turns out that if you have it in cloud storage, it gives me a few other benefits that, again, I go through later, but let's not worry about it. So in this case, rather than training directly off BigQuery, I'm actually extracting it out into a CSV file. And I basically get 3 CSV files, evaluation, training, and all. And basically, this is all just normal code. I'm using TF data, reading the data set, making sure the data is okay, then going ahead and creating my wide and deep model, doing feature engineering on it, training the model, and now I have my model. This is my entire Keras model with a whole bunch of inputs, with a few dense layers. And having done this, I now train my model. I have my model. It all works. So this is basically the first part of your data science workflow. And then if you want, you can go ahead and take that model and deploy it using G-Cloud, right? So you can deploy the model using G-Cloud into Vertex AI. So that's one way this would work. And then I can take this entire notebook, and in Vertex AI, I can basically schedule the notebook. I can say, okay, I would like to go to this notebook, and I would like to schedule it, right? So I would like to run a scheduled run of this notebook at certain times. And then because this notebook does everything from data preparation all the way to model deployment, I have everything ready, and it will basically be a runnable thing. So that's obviously one way that I could do this, but it doesn't really support the kind of orchestration and everything that I want to do. I want to automate it, right? So one of the things that I really believe is that notebooks are great for development. And you can use the notebook as a step of a pipeline. You can schedule the entire notebook, but really, right, for production purposes, put your code in Python files, right? Because you can basically manage them and maintain them using your traditional software workflows. Notebooks are great for data scientists, but for MLOps, for operations, for maintainability, nothing beats having flat files, having Python files. So what I've also then done, once I've developed the notebook, right, what I did was I basically took all of the code in this notebook and moved it into a file called model.py, right? It's pretty easy to do. You can basically go into your notebook, and you can basically export the notebook as a, not export it. Yeah, save the notebook as a Python file, right? And then basically remove all of the display stuff, and you basically have it. So all of this code is essentially the code that was in that notebook, but it's essentially now callable, and I added in a main, right? So that I could basically call it with a bunch of parameters like specifying the bucket, specifying the training batch size, etc. So once I have that notebook, right, and I've basically gotten this, we can now go ahead and try it out. So this model here is now workable, and I can basically go ahead and call it, right, with now Python 3 model.py, and I have a thing called minus develop, and I can go ahead and run this, make sure that all of this works. So great. So at this point, I have my code, but remember that in this notebook, I was doing some weird stuff. I was also calling G-Cloud commands to deploy the model. This is not Python anymore. This is Bash. How do I automate these? Well, you could do it in Bash, but that's not what I would recommend. Keep things in Python. Keep this whole automation pipeline in Python. So that's basically what I'm going to be talking about here. So remember the simple thing here that we're talking about, right? We're basically saying we want to develop a model, but having developed the model, let's look at this entire workflow: creating the data set, training a model, deploying to an endpoint, getting predictions, how to do that in Python so that you can automate it really well. So this is basically the workflow. So you've now taken the model, you've saved it. Now you can basically upload the model as a Vertex AI model, and then deploy the model to an endpoint in such a way that when a client request comes in through JSON, this endpoint basically invokes your model and sends back a JSON payload. And the endpoint doesn't contain just one model. The endpoint can contain multiple models and do a traffic split between them. So that's the basic idea. So the concepts here are, you have your model, just model files, you upload them into a model object, you put model objects into endpoints, and you basically do traffic splits in the endpoint between different models. So let's start with the first thing. When you want to train a model, you want to have a data set. Okay? So the reason that you want to have a data set that is in Vertex AI, we think of 4 different types of objects. A data set, which could be structured or unstructured. It will have metadata, it will have versions, so that you know, given a model, what version of data was used to train that model. That's part of the metadata of that model. The next thing that you will often have is that you'll have the model itself. You trained a model, now you have model files, your saved model in TensorFlow, right? Your machine learning model artifact. So those files, that's your model object. And the endpoint is the thing that gets called that contains multiple models. And you orchestrate all of these things using a training job or a pipeline, right? And the pipeline basically is take a data set, train a model on it, deploy to the endpoint. So essentially, the way you start is that you basically have, now in my case, a train on Vertex AI, right? And I basically initialize the AI platform. And I say my data set is a tabular data set. It consists of all of the files that meet this wildcard thing. So I'm basically using TensorFlow, right? gfile.glob, find all of the allstar.csv, and using those files to create my tabular data set. So now this data set contains a number of metadata information that is going to get passed along. You will not actually see any metadata in any of my code, but remember that underneath, Vertex AI is taking care of all of that for us. Okay, so we're basically getting a tabular data set, and it consists of all of these files. So that's pretty much it. So then in model.py, earlier we kind of knew what we were reading, but now Vertex AI is going to basically set a few environment variables for us. It's going to tell us what the training data is, what the evaluation data is, and what the test data is. Those are 3 true environment variables. And it's going to tell us where to save the output. Okay. So what I will do is that in my model.py, I will look for this environment data. And if it's not present, then I know that somebody is running it not in the context of a pipeline where these things are set, but they're probably running it from a notebook. They're probably running it locally, right? And so you can basically say, if that's not set, like hard code it to be where we expect it to be. Okay. So once you do that, you now have your data set created, and now you're able to train your model. So the training the model means that you have your model code, that's your custom training job, and you're saying, go ahead and please run model.py. That's your code, but in order to run it, we will need a container. Vertex AI works on containers. Everything is containerized. Fortunately, there is a pre-built container for every version of TensorFlow that you want to use. So in this case, I'm basically saying, like, I want to train on the GPU version of TensorFlow, and I want to deploy on the CPU version of TensorFlow, right? So basically, I'm getting 2 training image and the deployment image. That's the training image. This is the prediction image. I have two pre-built containers. And so when I'm training it, I'm saying, use this as your training image and serve it on the deploy image. So pretty much I can take my model.py and use it to create a custom training job. And once I've created that custom training job, I run the job passing in the data set, right? And passing in the accelerator type, the machine type, etc., that I want to do the training on. So bottom line then, you train your model, you create all the training code, and then when you're ready to train the model on some piece of hardware, what you do is you create a custom training job, providing the TensorFlow containers. This is where the prefab part of my title comes in. It's all already there, prefabricated. So just go ahead and use the pre-built container, pass in the hook for your custom code. And remember that your custom code, right, will basically use, this is the contract that your custom code has to honor. It has to read the data from the path pointed by these three environment variables and write the data to the path pointed by this thing. So if you look in my code in model.py, right? So basically that's what I'm doing. I'm basically setting the output there based on the output model there. I'm setting the training data pattern based on the environment variable, right? And if the environment variable isn't set, I'm basically dropping back to the original behavior I had in my notebook, right? My original notebook was basically reading train star. So I just keep that if I'm not running in a pipeline. If I'm running in a pipeline, I'm getting the place to read from the environment variable. The rest of my code remains exactly the same, right? Because all of this is basically just processing the training data pattern, evaluation data pattern, and that comes either from the environment variable or from a hard-coded value because I'm calling it from a notebook, right? So given those two things, at this point, I now have my model training done, okay? How does this change if you're not doing a custom model? Remember that this is if I'm writing TensorFlow code myself and I'm saying I want to run it here. Well, if you're doing AutoML, we will look at it. So we basically change this function, train custom model, to be train AutoML model. This part will change, but the rest of my pipeline is going to remain the same. I'm going to continue to use the same data set, but I will use that same data set for training a Vertex AI model, for training an AutoML model, for doing hyperparameter tuning. And then regardless of how I got my model, I'll deploy it in exactly the same way. So this is part of that unification that's super important. It doesn't matter how you train your model. This could be a PyTorch model, and you would still create the data set and you would still deploy it in exactly the same way. That's part of the power of this. You can basically switch any of these things in the middle and you have that unified workflow, making life a lot easier. So what if you're not using these pre-built containers that I showed you with TensorFlow? Well, there's two other ways that you could do it. You could use Kubeflow pipelines, and you could basically write whatever code you want, right? And basically have a base image and now create your own Docker image, write your own code, and use that to basically create a custom training job. And that custom training job is basically the stuff in the middle here, right? You need this custom training job, and you just do job run. Everything remains the same. You've just gotten a new custom training job out of your own container, out of your own code. So that's one way to do it. The other way to do it is to say, forget about all this prefab pipelines business. I will go use TFX. And TFX is a very prescriptive way of running things, where it basically provides you Python libraries for data validation, Python libraries for TensorFlow transformation, etc. You use all of those TFX components and you use it to create a pipeline object, and you run that pipeline object. Okay, so you have multiple ways of creating pipelines. I'm not going to talk about these two other approaches because today I'm talking about the very prefab, simple things should be simple approach. This is the more you can do hard things and hard things are possible approach. So once you've gotten your model, what do you do to your model? You deploy to an endpoint. So you want to create an endpoint. Now, so here's the thing though. You don't want to create an endpoint if it already exists. Remember the idea behind an endpoint. You want to do traffic splits. If every model keeps deploying to a new endpoint, it doesn't make sense. So you want to keep the endpoint consistent, and you want to keep deploying more and more models into the same endpoint and splitting traffic between different trained models as you go along. So that's what I'm doing here. I'm saying, go ahead and get me all the endpoints with a specific display name. and order it by the descending order of create time and take the most recently created endpoint. And that's the endpoint that I'm going to deploy. Ideally, you've only created an endpoint once. And then from then on, you're just reusing it over and over and over again, right? So create the endpoint with a specific name, this endpoint name, and reuse it over again. So once you do that, you can basically say model.deploy, passing in the endpoint, passing in the traffic split. So here I'm saying this model that I'm deploying, give it 100% of the traffic. If you want, you can basically pass in previously deployed model IDs and say that model has 30% and I get 70%, or vice versa. Specify the machine type that you want to deploy on, and that's pretty much it, right? So once you have deployed the model to an endpoint, you want to use it. So the way that you can use it is you have to basically create a JSON request. So this is what the request looks like. These are all of the input features to the model. So you basically go through and you pass in, you create a JSON thing and you pass that in. And you basically say endpoints predict and pass in your JSON request. So this is how you can do it with Bash, just to try things out during development. But obviously your client code is not going to use G-Cloud. Your client code wants to use Python, wants to use REST, wants to use Java, wants to use something. So if you want to use Python, you basically get the endpoint as before, and then you basically create a Python dictionary with the exact same JSON structure, and you pass in endpoint.predict, you pass in the data, and you get the set of predictions. Okay, so that's pretty much how you do it. And you can also do it using REST. You can basically use curl and you can pass in a specific thing. So it's just a REST API. So you can invoke it as long as you basically put your data in this form and you post it, you're fine. So now let's look at a couple of the other, like, how does it change if I wanted to tune hyperparameters? Well, if you want to tune hyperparameters, inside your model.py, you've got to do two things. First thing is anything that you want to tune has to be a command line parameter to your model. So if you want to tune the number of buckets that you're going to discretize your variable into, you make that an input parameter into your code, and then you basically write a Keras callback. So this is my hyperparameter tuning callback in Keras. I say at the end of every epoch, please report the metric that I care about, which is the validation root mean squared error. So that is my hyperparameter metric. And say report that, and then create a model, train it, and as you normally do. But when you call the model.fit, remember to also pass in the hyperparameter tuning callback. That's all you need to do. Now your Keras model is going to be reporting metrics as it goes along. And then in the training pipeline code, you bet the original job that you had, the custom training job, it is now just a single trial. So you say, give me a trial job from my model.script, and you use that to create a hyperparameter tuning job, and you train that job, and the result of it is going to be a number of trials. You sort it, find the best trial, and using the best set of parameters, you can basically go train it again, right? You train it all the way through. Typically what you do when you do hyperparameter tuning is that you train on a smaller set of data faster. And then like once you've found the best set of parameters, you tune that, you take those parameters and you train the model on the full data set for much longer. So that's basically what this is showing here. So if you go into train on Vertex AI.py, the hyperparameter tuning job is to basically create my custom job for my local script, passing in the model.py, saying, please don't evaluate on the full data set, just train on a smaller number of examples and go run this code for me. That's my trial job. And then my hyperparameter tuning job basically says I want to minimize my validation RMSE, and these are the 3 parameters I want you to tune. The training batch size, the number of buckets, and the number of layers and nodes in my DNN model, and run it for these many number of trials. And then once you run it, you get all of your trials, you find the best one, and you go through all of those, find all of the best parameters, and you basically go ahead and call the original train custom model, the one that we first wrote, with a full set. So that's pretty much hyperparameter tuning. How do you do AutoML? Well, AutoML means instead of training a custom job, you're going to use an AutoML tabular training job and run it. So here, right, the train, that's a custom model. Here's my train AutoML model. I'm creating the job. I'm doing job.run. I'm returning the model. So regardless of how I did it, I trained my data set. I did one of the 3 training jobs, AutoML or hyperparameter tuning or custom modeling, and then I deploy to the endpoint, and I'm done, right? I'm done at this point, and I can take this entire code, my main, and I can basically run that entire thing as a pipeline to basically get all my metadata tracking and everything going. Okay, so bottom line at this point, what we've done is we've created this workflow. You basically take your model in your Keras code, you've done a model.save, you upload the model, right? You deploy the model and you make it available for predictions. So to summarize, prefab training pipelines, they make simple workflows really simple. Developing a model, creating a data set, training it, tuning it, deploying to the endpoint, and getting predictions. Okay. For if you want to do custom or continuous evaluation, for example, all that you need to do is when you do the job.run, also export the evaluations into a BigQuery table and provide that BigQuery table to Vertex AI, and it will automatically start monitoring your metric and show you graphs of it. And then you can set up when this metric drops below a certain point, retrain, right? That's pretty much it. So it's very, very, very straightforward to start to add many of these amazing capabilities to this very simple starter point. Okay. So in summary, right, we talked about this simple workflow, like follow me on Twitter, lac_GCP. This I will leave here. Okay, the GitHub repository, which is probably the most important thing here, is this guy. Okay, so go there. Just one warning: make sure to switch to edition 2, right? Because so right there is 09 Vertex AI. So just remember this URL. I'll also post this in the chat. All right, and with that, I'll take questions.
Awesome, great. Wow, the Vertex AI really makes the machine learning tasks easy and the full stack. Yeah, we have quite a lot of questions. Let me bring up the slide for that. Just a quick reminder
for the link, right, of this, right? And yeah, so I just posted that, and if you go to GitHub, there is the IPython notebook. Okay.
Right. Great. Yeah. Just a quick reminder, for anybody for questions. Sorry, just a quick reminder, if you have questions, you can post in the chat or raise hand. We can unmute you to speak. Let's go with I have a few first questions. One question is there any further granular level control on where my endpoint will be deployed within a region?
You can do it within a zone. I would not go there. I mean, again, a region in Google Cloud is probably the most granular that you want to go, right? So specify a specific region. I mean, why would you ever want to basically specify a single zone? That doesn't make too much of sense, right? So stick to a region. Region is probably the most granular that you want to be. You might want to do a multi-region. You might want to do for like resilience purposes, but a region is the lowest granularity that you want to do.
Okay, great. Another question from Dave is, why are you using Jupyter Lab? Thought Colab is Google's version of Jupyter Lab.
That's the absolute. Colab is our free version. We have now for some people who wanted to use it in enterprise, we now have a paid version of Colab. But in Vertex AI, what we call Vertex AI Workbench is basically our development environment that provides enterprise capabilities like VPC service controls, encryption, multi-tenancy, a whole bunch of things that if you're running it in an enterprise, if you have confidential data, I strongly suggest using Vertex AI Workbench.
Another question is asking, is the Vertex AI free like a Colab or different?
No, Vertex AI is part of Google Cloud, and you will be a Google, it is definitely a paid service. It's not free. Okay. There is a free trial version of Google Cloud where you get $300 free. So definitely use it to learn, but now when you use it in production, it's not free.
All right. Another question. To clarify, the question from Chester, to clarify, are you claiming that Vertex AI can accomplish what Spark plus H2O plus MLflow plus MLrun frameworks will do?
Spark is larger than Vertex AI, right? Spark is a combination of data processing and machine learning. So if you're talking about Spark MLite, then yes, right? But remember that Spark also helps you do data preparation. So on Google Cloud, you would run Spark within Dataproc, right? So you could use Dataproc to prepare your data the way you do like large data sets with Spark. More commonly on Google Cloud, people use BigQuery to prepare data, but you can do Spark or you can do BigQuery to prepare the data. But once that data has been prepared, as far as feature engineering and training and low code, no code, all of these different frameworks, yeah, that unified framework, unified orchestration, you have scheduling, all of these things, absolutely. Don't buy individual things and glue them together. Buy something that is already well integrated, would be my thing. Yes, I am making the claim that other than data pre-processing, which is not, but everything machine learning related, you can do in Vertex AI. BigQuery plus Vertex AI is an extremely powerful solution, as is Dataproc plus Vertex AI.
Great.
Is there a way to use it for free while learning it? Yes. Again, Google Cloud offers a lot of things free for students. So go to cloud.google.com/edu, for example, right? And you will get a lot of higher education programs. Have your faculty members, if you're a student, register for it so that all of your class can get access to it. Strongly encourage you to do that. If you also go to cloud.google.com, there is a $300 free trial that you can use to learn as well. The third way to learn relatively quickly is quicklabs.com. Quicklabs has a number of all these labs. So if you go to Quicklab, you go to the catalog and you search for Vertex AI, you should see a number of labs that you can basically build and deploy machine learning solutions in Vertex AI. So that is this quest, for example, is an easy way to basically go through and learn all of the steps. And I know it says 35 credits, but Quicklabs usually runs all of these promotions where they basically give you like a month free. Just watch for those, and that's another way to basically learn this thing for free.
Awesome, great. Again, just a reminder, if you have questions, feel free to post in the chat. I see a lot of messages in the chat, so if your questions got screwed up or got skipped,
Lauren has an interesting question.
you can repost it.
Yes, okay.
Please go ahead.
Multi-model endpoints in Vertex AI are containers instances under the hood of the endpoint uniform. So you get to choose. So whenever you basically deploy to an endpoint, you basically get to choose how you're basically deploying. So when you notice in my trained at Vertex, right, I basically specify the machine type and I specify the scaling. In this case, I'm saying don't scale because I'm just start minimum of 1, max of 1. But you can obviously specify auto scaling here. Your machine type can be any machine type that's supported on Google Cloud, plus any accelerator type, which you saw when I did the training. I said train on NVIDIA T4. So yes, regardless of what the model is, you can basically do it on all of these things. Awesome. All right. For inferencing, what feature store do you use? It has to scale. Well, we do have this thing called a Vertex AI feature store. So take a look. Okay. With AutoML, how do you see this disrupting jobs in the data science machine learning industry? Look, here's the deal though. As a data scientist, what are you spending most of your time on? It's in understanding the problem. It's in evaluating models. It's in preparing data. I mean, it's not in creating the model, right? That writing that model code, face it, what everybody does. If you're doing image classification, you're using ResNet, right? If that gets replaced by AutoML, that's replacing a really small part of the overall workflow. And now AutoML doesn't replace data scientists. It basically gives you a faster way to go to market, to benchmark your models, etc. For IoT, it has to be millions per second. Yes, absolutely. So for IoT on Google Cloud, folks use something called data flow, and you basically do those in a streaming pipeline and data flow. So look up data flow, streaming pipelines, machine learning. We've had, for example, like we've had, companies like, for example, Talus does the scale that you're talking about, where they're looking at millions of events per second. They basically do it with like Apache Beam and TensorFlow. So take a look.
All right, I thank you very much. I think we are out of times. Great, thanks, Lek, for the presentations and the discussions, Q&As with the attendees. Thanks everyone for asking the questions too. With that, we conclude these sessions. Lek, do you have anything to add on before we?
No, nothing. Well, thank you very much, Bill, for the opportunity. Thanks everyone for the great questions, and I know online is really, really hard. So thanks for sticking through it and